Alright, what's up guys? In this video, I'm going to pick up some more calculus here. This is going to be another trigonometric integral that we're going to evaluate. So we're asked to evaluate the integral tangent cubed of 4x dx. So the first thing to do here is to rewrite this, and we can use the trig identity for it. So tangent cubed of 4x, that's the same thing as tangent squared of 4x multiplied by tangent of 4x. Now, we can write tangent squared of 4x. We can write that as -1 plus secant squared of 4x, because we know that tangent squared of x can be written as -1 plus secant squared of x. So since the 4x in there, we just modify it a little bit. And then the integral just becomes tangent of 4x multiplied by -1 plus secant squared of 4x integrated with respect to x. Now we do a u substitution. So what's the best selection for u? Well, since we have a tangent of 4x here, the best selection for u would be secant of 4x, because remember the derivative of secant of x is just secant of x times tangent of x. Well, if I let u equal secant of 4x, well, the derivative of that will be 4 secant of 4x times tangent of 4x, which will effectively cancel out the tangent of 4x. So that would be the best selection. And to differentiate secant of 4x, use the chain rule. And again, I'm going to bring the 4 to the front, so we'll have 4 secant of 4x multiplied by tangent of 4x dx. And then we'll have 1 all over that stuff. And you're going to easily see how the tangent of 4x will cancel out. So now we just essentially got our integral, and what's going to happen is the this secant of 4x will be replaced with the u, since we pick u to be secant of 4x, and this will cancel out the tangent. So in that particular circumstance, if we have that and we simplify it, we'll have -1 plus u squared all over 4u du, which we know we can break up and write as -1 over 4u plus u over 4 if we actually simplify it and then integrate it with respect to u. There are also, not in this particular example, but there are some integrals that, you can break up kind of like this using trig identities. And sometimes, especially if they reach a higher order, you can actually try using reduction formulas. In some cases, not in this case, we're doing it better, without having to use anything like that. But those are always in play if, obviously, you have a trig function of higher order or something. Because it starts to get to a higher order, it's hard to break it up. It just becomes a nightmare. Okay, so let's just integrate each piece of this and take it from there. So this is -1 over 4 ln absolute value of u plus c, and then we'll need the integral of u over 4 du. Again, you could pull out 1 over 4, so that would essentially give you 1 over 4 times u squared over 2, which will give us u squared over 8 plus c. And remember that u was secant of 4x, so we just got to put it back in there. So if we put it back in there, it looks like we got -1 over 4 ln absolute value secant of 4x plus secant of 4x squared all over 8. That's if we plug it back in. Okay, so we can actually go ahead and write down our final answer. Just kind of kill two birds with one stone. So we're asked to integrate tangent cubed of 4x dx. So the answer here is -1/4 ln absolute value secant of 4x. And this will be plus, I'm going to write this as plus 1/8 secant squared of 4x plus c. And it's very important to remember up here at the top, once we did the integration, it's very important to remember that we put parentheses around this secant of 4x, and keep in mind that we're squaring that. But we were not squaring the 8. There was only a u squared on top here. So be careful with that, because sometimes that'll get you. And I've seen it happen. It's happened to me, and it's happened to some students sometimes. You're just going through, you think you're doing everything right, and you're moving a little bit too fast, which I think we're all guilty of at some point, and you end up putting something you shouldn't. So just make sure you're paying attention to that. All right, so that's another trig integral. So I'll see you next time. Y'all take care.